Okay, so welcome to today's class. As it was said previously, this presentation was composed in such a way that it should go through the various use cases. You can see impact of AOP programming, the approach on these systems we are going to talk about later. And it was composed in such a way that it should disclose you what you can achieve with aspects, what you can achieve with AOP approach, what problems you can solve, and also what are the consequences of such an approach, what is the impact on performance, what is the impact on the software quality. So this is basically the content of today's presentation. Firstly, I'm going to provide you some general recommendations, which are either provided by the developers of the Spring framework itself or by the developers behind the tools commonly used for aspect-oriented programming, and then we are going to move slightly to those use cases. There are 4 use cases, 4 separate use cases. The first 2 are about the real-time systems. First use case is about the real-time, is about the impact of AOP approach on real-time embedded systems. Second use case is about the impact of AOP on real-time system. Third use case is about the impact of AOP on distributed systems. Here we are going to show that on 2 concurrent architectures, leader and follower, and housing and housing, which are 2 distinct concurrent architectural patterns. And then we are going to talk about the innovative approach, how you can use aspects on Android devices, because there were some issues related to that. So we will talk about it later. So here are some general recommendations. Well, compile time viewing is generally considered to be much faster than runtime viewing, and some common knowledge is that AspectJ is almost around 8 to 35 times faster than Spring AOP. Well, Spring AOP works with proxies, but these proxies are created only at the startup of the application, and you can also ignore this performance overhead if these proxies are meant to implement, or your aspects are meant to implement longer running operations such as database access. But it doesn't have to be only database access. You can use aspects to implement transaction management or assignment of tasks to the threads, or you can use aspects to the state management, you can use aspects for even lazy loading. There was a benchmark conducted with 4 AOP frameworks, and output of this benchmark is that AspectWorks was shown to be best performant. AspectWorks is just another framework being used for aspect-oriented programming. It's a framework for Java, and as you can see, that Spring AOP is worse in this case because it's proxy-based. This benchmark was conducted in such a way that there were aspects, but these were empty aspects, thus catching minimum requirements of this approach. And these aspects were called 2,000 times on Java server architecture. So I think that we are still going to stay on all these recommendations. Well, as I said, Spring AOP is generally slower because of its proxies, and these proxies are being used as containers for aspects and target objects implementations. Well, proxy is in fact the implementation of the decorator design pattern. These proxies are created only at startup, so you can maybe ignore this performance overhead, and if your aspects implement additional running tasks, which is transaction management, this performance overhead is negligible. If you need to add finer-grained behavior in aspects, or if you need to apply finer-grained behavior in aspects to a large set of objects, it's better to use AspectJ approach. One advantage of the AspectJ is that it at compile time it performs a few optimizations. So some optimizations can be performed only at compile time by aspect JVever, so that is one advantage. Such as well, and these optimizations are, for example, that unused variables are removed or statements you wrote in your aspects are replaced by more efficient ones by aspect J compiler Weaver itself. So that's about these heuristics, and then we are going to move slightly on the real use cases. So first use case is about the impact of aspect-oriented programming on real-time embedded systems. Well, in my first use case related to real-time systems, these researchers were interested in the impact of the AOP approach and the introduction of aspects on both software quality and real-time embedded systems performance. These are just two different things. And they were able to show that introduction of AOP to their software project helped increase both of these characteristics, that is performance and software quality or software quality attributes, and I will show you how. Well, software quality is being evaluated in terms of the system properties, and these are the properties which indicate software quality. These properties are understandability, reusability, maintainability, and testability. And there are, of course, some most commonly used AOP metrics which you can use either to evaluate effectivity of your AOP approach, but also to evaluate effectivity of your AOP approach as well. So, for example, if you achieve low coupling between objects or low value of the CBO metric coupling between objects, then it might mean your system exhibits good modularity and it's somewhat better or well structured. If you are asking why to talk about the impact of AOP on quality and performance of real-time systems, it's because you can find a lot of research papers about its impact on desktop systems, but few papers talk about its impact on real-time systems. These researchers were also able to show one example of a real-time embedded system that introduction of AOP helped them to achieve better performance metrics. In this case, better memory usage and CPU usage. What they basically did here is they had an audio switch project or audio switch software and implemented these cross-cutting functions in both OOP and AOP, and then evaluated its impact. But this is a common pattern in research that cross-cutting functions are first implemented in OOP approach and then in AOP approach, and then it's been subsequently evaluated. So they were able to show that on 4 of most commonly used OOP metrics, AOP approach helped them to modularize the code and make it better testable, reusable, maintainable, and understandable as well through these metrics. But as I said previously, these attributes are just characteristics of the software quality itself, not of performance. And they were also able to achieve better performance characteristics of their audio switch software, which are critical in such a system, because audio switch would otherwise play the same audio sample more than once, which would be kind of strange. So they have achieved better performance, mainly the one reason that they have significantly decreased the number of messages which had to be passed between objects. So that is why. Then second use case is too about the real-time system, but this use case is about the impact of AOP approach on real-time traffic management systems. So there was a separate systems being used. Here, another set of researchers, in this case from Trinity College in Dublin, were searching for what AOP approach does to system properties. So they have used a traffic management system as an example with its real-time constraints and implemented this traffic system in real-time Java and both in OOP approach and AOP approach, so this is a common pattern in research. And in terms of the impact of AOP, they were primarily interested in whether AOP approach helps to achieve better usability, maintainability, testability, and reusability of the code. In terms of the tools, they have used AspectJ and real-time Java, which is Java for real-time use cases. They couldn't use plain Java because it was basically unsuitable. Real-time Java software development kit addresses additional real-time constraints or the real-time cross-cutting concerns which are not addressed in plain Java software development kit. If you had a question why they have used a traffic management system as an example, it was because this system was meant to be it was meant to control self-driving vehicles, and these vehicles must be able to react on unexpected events in a timely manner. And if such a system would be implemented with a plain Java or with a plain Java software development, its threads could cause reaction delay of these vehicles on the road. So, and in their approach, aspects help them to override default management of objects and threads, which in turn led that they were able to manage actions taken by the cars without delay. So, results of these experiments provided that using aspects increase modularity and testability of the code, because in this case coupling between objects metric has turned a significant negative value, and it turned this value in modules handling memory access and event handling, which was good in this case. But they were also able to show that introduction of AOP increased understandability, reusability, testability, and modularity of the code because of these metrics. So, AOP approach had a positive impact on software quality. Here you can see that object-oriented metrics are related to the attributes of software quality. For example, because a CBO metric has turned a negative value, we can say that introduction of the AOP approach slightly helped to modularize the code, and it made the code better understandable as well because of the decrease of subclassing, which you can see in the metrics depth of the inheritance tree, PIP, and in the metric number of children. So that was the second use case. This use case is about the impact of AOP on distributed programming or distributed systems. And in this case, researchers postulated two hypotheses. First was where they wanted to answer the question if a program is affected negatively after introduction of aspects to it. And second hypothesis was that they wanted to answer the question if the increasing number of requests which must be served by the server from clients is negatively impacted by introduction of AOP. So they wanted to answer these questions with distributed systems, namely with systems implementing two concurrent architectural patterns, in this case leader and follower, and housing and half-housing. So we have two distinct concurrent architectures. Cross-cutting concerns they were dealing with were requirements to synchronize access to message queue or thread management, and that is which threads should be activated and which task they should run. What they got from their experiments is that in some concrete circumstances, AOP-based leader follower pattern performs better than half-sync and half-async architecture. As you can see in this case, AOP-based leader follower or half-sync, half-async architectures are performing basically the same, with about 320 threads are managing the pool. That is the edge case. But half-sync, half-async architecture performs better if a small number of threads is being managed in the thread pool. And these are the parameters which you can choose on your own, because frameworks allow you to do that. But statistically, performance of these two concurrent architectures implemented with OOP approach and AOP approach is basically the same in the long run. So there is no impact of the AOP on these distributed systems. So these are two hypotheses they initially had. First hypothesis was that performance of concurrent systems is impacted negatively by introduction of AOP. This turned to be statistically not true. And second hypothesis they had was that the number of requests sent by the clients increases performance degradation after introduction of AOP. And this also turned to be statistically not true because of this graph. So
what was the system, the underlying AOP approach they used, or whether they used aspect J or?
Yes, they had
aspect J.
Aspect J.
Interesting.
Okay, so we are moving slightly to the last use case, and this use case is about viewing aspects on Android devices. Your question arises, why do we want to view aspects to Android application? Well, there are few use cases, such as a company can enforce a security policy on mobile devices of its employees, or you can implement your own ads blocker with them, or you can strip Android application from internet access when it tries to load ads from URLs. So that is another use case. Situation before the introduction of the ViewDroid was, and ViewDroid in this case is just another application available on Google Store. So situation before the introduction of ViewDroid was that if you wanted to view aspects into an Android app, we first needed to have its code, download that code, view aspects to that code on a separate device, that is important in this case, and then upload this code back to the device, back to the Android device. But things changed with this tool, because there is a tool which you can use as a cloud, so you provide your URL to your app, to that tool, and code of your aspects, and it gives these aspects for you. But still, it's better to use embedded viewing, that is, view aspects on the separate device, because it has still some advantages over the cloud-based approach. Viewing purposes almost doesn't depend on the size of the actual application. That is the advantage why you should use embedded viewing instead of the cloud viewing. So, and here are the references. These are primarily research articles, either from ACM or IEEE, and I will provide you this presentation as well after the class. So that's all from my side. If you have questions to any of these slides, I'm here to answer these questions.
Well, thank you for your presentation. We have plenty of time for discussion. So maybe we can discuss these performance things. I mean, as you said, if there are any immediate questions to what Viktor presented, please go ahead. But then I think it would be nice to hear from you if you have some experience with performance issues with AOP, or how do you consider that topic serious to be, not limited to aspect J or Spring, whatever. So any immediate questions, please go ahead.
I would like to ask if application in embedded system is only in this presented case as is a special case, or it can be applied on every embedded system and every case.
It can be applied on any case, on any embedded device.
Okay, thanks.
Short and clear answer. No doubt.
But you must know that these embedded systems have slightly less computing power than, for example, desktop devices. They are using less powerful resources. CPU. They have less memory.
We had some two papers on this. Well, one was much more related to this regarding this topic, specifically with respect to Android. Some time ago, that came out of the projects that realized within this course. So maybe we can. I'll put those two references under this lecture website. So I also have to fix the title there. And one thing that comes to my mind with respect to what you said, Viktor, is you mentioned how around advice is worse in performance than other types of advice. Not that much, maybe around, but this study, it's not here, but did you come across the problem with the after advice? After advice.
Well, in this benchmark, various advices were used. There are just two of them, but there were more of them in this benchmark. So
maybe it was there. You don't know.
Maybe I think that it was there, but just
because after
incorporated.
I think after advice is quite a problem. You know, maybe you saw that there are know that there are two subtypes of this around advice: after returning and normal after, and maybe is there another one that treats only the exceptional case? I'm not sure. After returning is only if it's successful, and it's much more efficient than the complete after. So if if you work with this, then like applying AOP in some real situations and for real purposes, then this does not come as an obvious thing, but you have to pay attention to these things, and especially in the after advice is quite a problem. So whenever you can, you know that you do not have to deal with exceptions, and you use after returning, and it's much cheaper to use that in terms of time.
But in the case of performance, they are similar, no? These two advices.
I think no.
The logic is always the same.
Yeah. Like the logic is the same. That's not a problem. So shouldn't it be with the problem? Shouldn't there be a problem with efficiency? You could always use the complete after advice. It's not a problem, but this one after returning gives you some I don't know.
Activate the aspect only.
Several times less time necessary for it. Then so it's much better to use it whenever you can, whenever you know.
It's probably much more safe to use, especially if we are using aspects in some security application, something like that. So if we would like to implement some security aspects in our application, then we obviously don't want to activate those aspects when we receive some exception. So error in the code, in the input probably. So I think that after return, yeah, especially usable in case of security topic, security field.
Yeah, that's another thing, not just the performance issue, but safety issue. Okay.
Do you think probably that after advice will be similar in performance to the before? Because they are implemented. Well, because around is observing the whole function implementation, how it works, not implementation but execution, to find some point, some join point in the function itself. But when we are doing with before or after, we just waiting for the function to be called or to return something. So I think that it can be probably similar to the before device.
We might expect this, but I think there's quite a difference. That before is several times less complex in time than the after advice. I never studied these things. I was never that much interested in performance issues. I've just taken it as a kind of reality that AOP will never be that efficient as OOP, and if you want to be really efficient, then you can use assembler for purposes. But it's all with all higher level programming languages. It's like that. That whenever there is a new feature added to the language, it adds some burden regarding the efficiency. So it's normal. Like even polymorphism. That's why you can turn on and turn off polymorphism in some overriding in some languages. In C#, and in C++, if you don't turn it on, actually, like by virtual keyword, you will not have it. because there are many cases that when you don't need it, and if there is overriding activated, then there's another level of indirection added, and so on, and everything takes longer. These are things that we expect with aspect-oriented programming, and I was mainly amazed with, by the power of aspect orientation, and how you can address many different, really different points in your program by really simple code. So now maybe we are like in a wider discussion. With respect to what you think you find, like maybe you are applying. I never asked you in your practice if you are employed somewhere and you work on some projects or something. Maybe you have managed to apply some things, some aspect-oriented things. Has anybody had a chance to do that in your regular work?
Caching by decorators.
Yeah.
You mean decorators as an inbuilt function of some language, or as a decorator
in
Python?
Python, yes. The general function which takes on...
Yeah, but it is not an aspect. It is a functionality that is similar to aspect in...
Yes,
Yeah.
in Python.
Oh, for example, yeah, I think it's applied some time. It's really useful. Probably it is not as performance effective as an aspect, for example, in ASP.J, because it's not so native for the language, or for example, as probably aspects in Spring AOP are less efficient as well. But I think they can be used, and I'm a little bit confused because you, Viktor, said in your presentation that OOP is less performance effective than AOP in that 100 experiments. Some relation.
Which case are you mentioning?
Yeah, this one. Other switch project embedded real-time performance metric. So I'm a little bit confused that why the AOP approach is so rarely used, because it seems that it's just more effective. Because of the common AOP problems in usage, like dependency on the some code convents, or for example, if we use AOP, the code is going to be a lot less readable, or because of some other problems. AOP is less used than OOP approach, just commonly. I'm sorry if you said something in your presentation about it already.
This is in ASP.J?
Yeah, but
Yes, it is.
I'm not sure.
I'm a bit confused by your question.
This comparison of AOP and OOP were done in the ASP.J.
Yes.
Yeah.
ASP.J was used.
Okay, I probably understand why it's so effective, because ASP.J is probably the most effective approach of usage of IOP.
Yeah, but we don't know really what kind of advice were used here.
It doesn't matter.
So it
Because
does matter.
it can be that we have some program
So
which use different advices to implement the same functionality.
yeah,
And we just measure how much
but
time it does
if
take.
they preferred before over some of the other types of advice, then I would expect
In this case, mainly around devices were used.
around.
And before and after devices were used for tracing, that is for logging messages. But Do you have any question, Jakub?
I only want to add that I asked the first question because it's special case because they decrease number of messages and because of it they decreases the performance, not by comparing aspects with AOP in mainly the casual cases and so on, and because of it I ask if it's a special case or it can be used in different contexts which are more regular ones in comparison with this one.
I think you can employ this approach on various types of embedded systems. Depends on the concrete circumstances.
If we get back to your experience or your expectations with AOP, what do you think of this? Would you do you think this performance side will be the deciding point for using or not using AOP for you in your further practice? How do you find this? Or what's your I guess apart from what Jakub said and Viktor said, there are no you have no experience yet with applying, haven't had a chance to suggest or to promote aspect-oriented programming work. So, what are your expectations with respect to this?
Probably we don't have much experience except of our project this semester. But if someone of us did some comparisons of the application of the aspects in, for example, aspect J and some other language, so I mean implementation of the aspects in some other language, then I should say that usage of aspects is really helpful, and I expect that it will be at least a comfortable way to implement its functionality instead of usage of decorator pattern. Because decorator pattern, yeah, it can achieve a part of the aspect functionality, but it's not comfortable at all to implement it in the code. This to embed some class, some function in another, the code becomes a lot less readable for the coder, and if we will use it a lot, then I think it will be a big problem for some other programmer who will read this code without knowledge about what we are doing here. It will be a problem. But with aspects we just can implement some function and say that apply this function to this one, not without some embedding, without some code replacements or something like that. So yeah, I think that if AOP is used correctly where it has to be used, then I expect it, and that's what I have received in my project, that it really increased readability of the code and it was more comfortable to use. And probably, I don't know, more efficient if it is a native implementation of the language which I use.
You're doing with decorators, but...
Yeah, I mean...
Well, Roxy design pattern is implementing decorator design pattern. We can say that. What are the implications of your approach? Because can we say that Roxy-based approach is aspect-oriented approach?
Probably, if we count that it implements design patterns, that it can be said that it is an aspect-oriented approach, I think, because one of the goals is to achieve a similar functionality that we can get using aspects?
Mm-hmm.
I'm not sure because I'm not professional in this field, in this topic, but I think it can be at least partly count as an aspect-oriented approach because of the functionality we receive by using it. One of the goals is to implement
Even
aspects.
Hibernate
Mhm.
uses these decorators.
As a constraints, something like that, to apply some functionality to the database and so on. You mean or what?
Oh, I don't understand you.
No, Hibernate is a ORM. You mean
Yes.
yeah? And I've used Hibernate before, and what I've seen is it can apply some constraints to the functions, to the fields of the classes, those classes, the way similar to those proxy.
We uses decorators, for example, for lazy loading, or
Yeah.
then we could say that Hibernate is in fact aspect-oriented, because there are a lot of decorators in that.
Yeah, I understand.
Either for optimization or for other use cases such as lazy loading.
But those aspects are mostly pre-implemented. For example, to check some variable when we input some data. I don't know. So it is not as flexible, in my opinion, because we can write some function and then say that apply this function. We have to use Spring AOP for such a purpose. But probably Hibernate is also to aspect-oriented software framework.
In some way.
Yeah, in some way.
Yeah, that's an interesting point. So it's kind of these are more like technical aspects, but we might see this also as domain specific implementation, and the use of aspects is limited there. Maybe this is a way to go for some applications, because people feel more comfortable with this, because there are not too many choices, but yet it helps express some things much more efficiently, in a simpler way. There will always be a problem with using dedicated compilers like AspectJ compiler, because there is a kind of a lag in following the development of the underlying language. So you will not manage to have the current implementation of state-of-the-art compiler for each new version of the underlying language. But then again, organizations usually stick to some version of when they use Java, for example, they stick to some version of Java, and they do not frantically transition to each new version that comes about. So the other perspective is that you might came across some things, or did you or have you by now encountered some situations in your real programming work where you would apply aspect-oriented programming just to speed up some things and demonstrate some functionality? Then you could take time to implement it in a kind of traditional way without using aspects, but for the time being, when it is necessary to demonstrate the thing or try. Demonstrate means also to try something, because you can play with it, and other people can play with it once it's implemented and come to some different ideas. and then say, okay, we want this or we do not want this. Have you had such a moment by now? Oh, it would be good to apply aspect-oriented programming there, just to show people something quickly. No. Think about that. That's yet another way how to use aspect-oriented programming in the past, and not maybe it's even now, but it's used in different languages. For quick prototyping, functional programming was used very much in Lisp. It was very promising because you could put together very complex things in short time and a few lines. I'm not a big fan of Lisp and its syntax. It's all in parentheses, but lists and so on. But it was conceived like this, and even aspect-oriented programming, as you know, started with this. The prototyping phase was managed in CLOS, Common Lisp Object-Oriented System. So it's interesting that then aspect-oriented programming kind of took this place of being able to provide this prototyping, quick prototyping approach. So think about this as a possibility as well in your professional life. And I always forget to invite students, but you know, people forget about things, and you will forget about this course maybe very soon after you finish your studies. But I do hope that some resemblance will be still in your mind. If you come across anything in your professional life like this that you would like to kind of return to us, so we'll be here, and maybe it will be nice to I'm not saying that you should bother with coming to present something, but that would be also nice. But brief information that you're using some things related to this course and related to aspect orientation would be very nice to hear about. Okay, is there anything else we should discuss regarding this lecture, this topic? Doesn't seem so. Do you want to continue immediately with the presentations so that we can kind of finish this earlier with this plenary part, and then consultation part will be for those who do have to consult something?
I personally would like to continue because it will take probably something like 40 minutes and we will be free if we need.
I will leave it to those who are actually going to have
Yeah,
those presentations.
We'll present.
So it's up to them.
Nothing else.
I don't really care if I can let it now.
We can start now, so we don't have that.
Yes.
Yeah, okay. So let's start with the presentations.